In this series of lecture, we are going to learn how to use KNIME. Now, KNIME is, as you see here, is a data analytics platform. It's a low-code, no-code platform that anyone can practically use. I would say mostly useful for executives or managers who are not necessarily data analysts or data scientists who don't do, let's say, programming with Python or R, but they would love to do some analysis to have some insights from their data, to get some understanding of their data or how their, let's say, their company is performing. So for any purposes, when you have some data and you want to do some statistical analysis and you're not ready to go for programming, then you can definitely use this platform, a wonderful platform that, as you are going to see, we can basically drag and drop, pretty similar to the figure that you see here, different nodes from here and there, and connect those to conduct the analysis and get our output from there. For example, you can perform a t-test, you can do ANOVA, you can do regression, you can build a predictive model, and even you can do neural net, deep learning models as well. So whatever your need is, pretty much all type of data analysis you can do using this platform. And a wonderful thing is that it's free, it's open source, so you can download it to your personal computer and just go from there. In this particular lecture, I'm going to show you how to download KNIME, install it, and how to get it started. And we will also do a correlation, build a correlation table just to get started. And in the later lectures, I'm going to show you how to build and perform other statistical analysis.
Search for KNIME download. Go to the first link that you see here, and then you can download it right from there. Now, I strongly suggest you to create an account as well, because in the future I will show you that you can use KNIME AI for different purposes. And to use KNIME AI solution, you need an account because they're connected to their online platform. So anyway, so click download the software, install it to your computer, and then we start from there. It might be a little different, but they all are completely fine. Simply click on the home tab and just come here. So here you can see three different options. The recent is of course going to show you all the recent models and the um, analysis that you completed. So these are different tabs that you see here. These are also the same thing that you can see at the bottom under recently used workflows. Local space is your document. So in your home computer, wherever you have the document section, so the document tab is, and all the files from the document tab you can browse here. I strongly again suggest to create a folder, name it IT5603, and then inside you can basically create different folders again. For example, I created one to save my data, so all the data that I will be using, I can keep it here, and automatically it is going to also save all the models or workflows that you create under the same folder, under basically under document and under whatever you create. So you can save it. I will show you how to save it to a specific location, and you can save it here. So this is how you can keep it organized, and you don't have to look around everywhere in your computer to find the file again later on. All right, so then third one is KNIME Community Hub, and this is simply the online community that someone has let's say asked a question and someone else also replied to the question, so you can get help from there. We rare personally I don't use this option, but if you need help you can definitely connect and see if you have any solution available there. All right, so let's go to our local space and browse the data that you have. So for me, I have two data sets. One is the Airbnb test data that I'm going to use for model building, and I also have a smaller section test data that I will be using for testing my models. So the HBL is my, basically I'm going to use this one for training my model, and the Airbnb test is the one that I'm going to use for testing my model. Now that if you already covered the lecture videos, then you should understand that for any machine learning models or deep learning models, we use two or three subsections of our data. So we first train our model, let's say with 70% of our data. Then we test our model with 20% of our data. And finally, we validate our model maybe with 10% of our data. These are arbitrary numbers. So you can use 70, 20, 10, or you can go for 60, 30, 10. So this is fine, or even 80, 10, 10. Anyway, so let's start with creating one workflow, and that will introduce you to the software and to the workflow as well. So let's start our first workflow by clicking the plus sign here. I have a couple of tabs open, so for you the plus sign will be somewhere here. Simply click on the plus sign, give it a name. So for example, I can say correlation. So maybe I will say project core. Great. And now you have this interface. All right, so let's browse the interface a little to get introduced to it. So the first one is, it's called info. So whenever you drag a node here, you can click and see the information related to that node right here. The nodes are given under nodes. You can search for a particular node, or you can simply click, drag. I'm going to show you again, and collect it from here. Explorer is to browse again the same folder, where the default folder that KNIME has access to. It's primarily your document folder under your home tab in your, of course, in your personal computer. So the fourth one is called KAI or Kai. Now, what is Kai? Remember that I mentioned the AI assistants that you can get from KNIME. Now they have introduced this assistant, and it's very convenient. You can use this one to search for answers, search for solutions, search for suggestions. If you want to use Kai, you have to log into your account. The account, remember I mentioned earlier at the beginning that you should create an account on the KNIME website. So they basically connect you to their website. All right, you can click on this one and accept and continue. See that here in this box you can search for uh, suggestions, basically for nodes that you're going to use. So those nodes will be used for building our model. I'm going to show you a few in the future. So let's continue from here. And finally, this is called monitor. So this is to monitor the workflow. Most often the one that you will use is this one, the nodes one, and the Kai one. So let's start with the Kai. I can write conduct a correlation. Simply write whatever, as a human language, whatever you want to do. And it's going to suggest you a few steps, like connect your data, select your columns, configure the node option, and then execute the node. Let's find out our first one. Connect your data table to correlation node. Let's find read CSV. It is going to suggest you CSV reader. So we can go and find under our nodes here, CSV reader is available. Simply click, drag, put it here. I'm going to make this one a little larger. If you want to make it a little larger, zoom in, then click here at the corner, go for 150. So that is going to show a little bigger. See that this is CSV reader. This is our first node to read our data file as a CSV file. If you have, let's say, an Excel file, then search for Excel reader, and it is going to, right here, it is going to show you at the Excel reader. So you will be using the Excel reader instead of this CSV reader. All right, you can write down a name or a comment here simply to if you want to put more information that what this one or what it does, you can do that. I'm going to write simply read data, right click and configure. So when you right click and configure, it is going to first show you an option to read your data and select the path to your dataset. Click browse. Wherever you put the data, go there. So remember I said this is under my document. I have this folder IT5603 data. I'm going to use Asheville. Remember this is for my training. Open. It will show you a glimpse of your data. Read very carefully to see if the system read your data correctly or not. And the second tab here under transformation, you can also click on this one and see the columns that the system automatically selected and read for you. Click apply, click OK. If everything is okay, simply click apply and OK. Now your data has been connected, but your system did not read it yet. To read your system, you have to execute this particular node, right? So to execute, there are a couple of ways to do that. First, you can click on this one, come all the way down here and select execute. Or you can simply see this play button here. You can click on this one and you can execute this node. Or you can simply right click and see that the next option is execute. Or you can press F7 as the system suggested. F7 on your keyboard is also going to execute this code node. All right, so this node now read our data. If you want to look at your data, right click, go to the second option. It says open output, go all the way to table, click, and now you can see your data in a table format. So see that we have all these columns available related to an Airbnb listing. You can also go to the Airbnb the website and see for these options. The final one you see indicates if a person is superhost or not. The host is a superhost or not. All right. So now we read our data. Now what? For any data analysis project, we need to check a few things under our pre-processing step, right? We need to read our data, check for, let's say, null values or missing values. Then we can also do a couple of more things. For example, check for zero variance. So if a data set or column doesn't offer any variance, for example, all the data is either 1 or all the rows for that column is only zeros. So this is going to be a problem because it doesn't have any variance, so it is not going to be useful for us. We can get rid of those type of columns. So lots, as I said, lots of things we can do. So let's go to our search for nodes and search for missing value. Find this one, drag it again here. Now we have a second node. It has all the properties like earlier. Remove and simply say whatever you feel relevant. Again, remember, we brought this node, but it is not active yet. This red mark shows you that it has not been activated. Once you configure a node, it is going to be yellow. Yellow indicates that it is now ready to run. And when you run a node, it is going to be green if it successfully run. All right. So again, click, right click, configure, and it shows you that the dialog cannot be opened for following reason. There are no columns. The reason is that at this moment it is not connected to your data. To connect it to your data, we have to connect it back to our reader. Simply drag this arrow, connect it to the endpoint here, and this is how we make a connection between nodes. Simply connect the arrows. Now you can right click again, click configure, and see the column settings and other information. But most often we don't do anything really. You can do, for example, if you say that okay, if you find an integer make it float. If you find a missing value for integer column, do what? If you find a missing value for number column, do something. So you can either replace it by, let's say, minimum mean, replace it by max, or you can just simply remove the row. So you can do all these things based on which type of data your system is finding. If we say remove row, let's say remove row, and finally remove row. So that simply means if you find a missing value for any column that is of integer type, remove that entire row. If you find a missing value for any float type column, then remove that entire row. For a string, again, remove that entire row. Click apply, click OK. All right, now see that it has been turned to yellow. That means this node is now ready to run. Let's run. All right, now our data has been cleaned. If we had any missing data or any value, it has been removed. Now you can right click and again go to open output port, go to output table. You can see the same table, but as I said, there are no other changes other than removing missing data. This particular data set does not have any missing data, so it did not do anything. All right, so now that we have removed our missing data and everything, we can now filter our columns. Remember that usually in our data set we have lots of columns or variables, and we often don't need those columns, correct? So what we can do, we can get rid of some of the columns that are not useful for us. So we can go to column, and then let's say filter, find it from here, drag it right there. And this is again, as I said, filter your column. It is going to do filter columns. You can use this one to remove any column that you don't want for your further analysis. See that when you click here, there is a dialog box open here, but it does not have any data or any information that we can use. That's again because you did not connect it back to the previous steps or previous nodes. You have to connect it right like this, and now you can see all the columns that are included right now in your data. If you want to remove any column, you can simply find it. For example, for in our data, we have one column, superhost s, that is a string, and I hope you understand that we cannot really calculate any correlation with a string column. So what I'm going to do, I'm going to click and use this back button to move it to the excluded list. So the rest of the columns are basically good, but if you want, you can also remove these binary columns if you want to. Let's say I'm going to remove these binary columns for now, all these binary columns. So now I have only numeric columns. All right, all numeric continuous columns. Let's execute this one. I forgot to click apply, so you apply and execute. So this is how you get rid of all the columns that you excluded. If you want, you can open the table, and now the table will have only columns that you included. Next, we need to calculate our correlation, correct, among these columns or variables. So to calculate correlation, we can simply search for correlation again and find linear correlation. Remember to connect it back to your data, configure. If you want to exclude any from here, you can again select, use this one, this back button to put it back to the excluded list. Here you can select if you want to include all column pairs, or if you want to include only column pairs of compatible columns, or you can include only column pairs with a valid correlation. So we can go with the default one, include only column pairs of compatible columns, and then you can select the p-value as two-sided. For most often, we can just leave it as it is, the default values. Only see if you need to exclude any column or not. Click apply and then click OK. Now your linear correlation node is ready. Execute, put a comment, and now you can again click here for correlation measure and correlation matrix. Click on the correlation matrix table, and now you can see the correlation among these variables. Now this is the same information on both. It is like diagonal here going this way, and the same information is also presented on the upper half of your table. So the lower half and the upper half are same information, only given in two different ways, right? So we can look into only the lower half to see the correlation among these variables. You can, if your column name is uh, shortened like this, you can put your mouse here and drag this first column a little bit to visualize all the names for different columns. All right, so now you can see accommodates has a correlation with accommodates equal 1. That simply means, of course, the same variable with itself has perfect correlation. Bedroom with accommodate has a positive correlation and quite high, 0.89. That means we can understand that the higher the bedrooms, the more a house can accommodate people, right? Guests. We also have the same level of correlation with beds, positive high correlation, because the more we have beds, the more people we can accommodate in an Airbnb. Rating has a positive correlation, but it's smaller compared to bedrooms and beds. And see that these numbers are the correlation for this variable with this variable, with this variable and this variable, this variable and this variable. And this is how you can check the correlation for each variable with the, the variable name that is given in the first row here. For example, then this number represents a correlation between per night price and UBV score. Again, if the column is like this, you can drag. So review score accuracy, it was accuracy. So accuracy and per night price has a correlation that is positive, and the value is, as I said, quite small, but it is still positive. All right, so this is exactly how you can calculate the correlation among your uh, data variables, and you can see and visualize the table and have a feeling of, okay, this variable is correlated to that variable and it is positive or not. And if you have a defined dependent variable, for example, in this particular case, my dependent variable is per night price, and I can check which one is positively correlated with my per night price. So per night price is right here, and I can see the first column, that is right here. I'm going to make it a little bigger. So my per night price here has a positive correlation with accommodates, has a positive correlation with bedrooms, has a positive correlation with beds. Then here, all right, so now it is sorted based on which one has a stronger correlation with our per night price. So the first one, the strongest one, is our accommodates. So the bigger a house has, or the more number of people a house can host, it has a higher price, and that's very understandable, right? Similarly, see, remember the bedrooms and beds, both are also representative of how big a house is, and both of those three, all three, are positively correlated with our price. Larger house, higher price. Accuracy, so these are review scores, and the higher the rating, of course, all of those should have a positive correlation with our price. And exactly, we see all of those ratings have positive correlation with our price. Now this one interestingly has a negative correlation, and this one has a negative correlation. What are those? Check-in review score has a negative correlation with price. That means If someone's house has been marked as good or high on the checking, they usually offer their house also a little cheaper. So that can be because they are trying to make it more accessible for people, for future um, rating or something. But however, the checking rating has a negative correlation, and number of reviews has a negative correlation with price. That means this is understandable though, because the number of reviews represent how many times the house has been rented before, and the higher it has been rented, we can assume that if your house is too pricey, then of course very few people are going to stay and rent your house. But if it is, let's say, moderate or lower than the average, more people will be interested to stay in that house. So of course, the higher reviews we have, that means the more people stayed there, usually the price is lower. So this is very intuitive and understandable. All right, so I'm going to end our today's practice session here. In the future lectures, of course, I'm going to go into more advanced models and everything, but I hope that gives you an introduction to KNIME, as well as how to run a correlation and find your correlation matrix. Use this with this and complete the same exercise with a different data set. Under content, go to data and find a relevant data set that you can use, or follow the instructions if that is an assignment. Hope it helps. Thank you.